All right, so when you're graphing, you want to check to see if it is in standard form or vertex form, okay? Number one here is in vertex form, and we know because it is in the form y equals a times x minus h squared plus k, all right? So from this, we can go ahead and kind of start filling in the gaps here. So here, the first thing I kind of notice is my vertex, which is going to be negative 3, 6, all right? You switch the sign of this guy, keep the sign of this guy. Then my axis of symmetry I get from my vertex, so I'm going to say x equals negative 3. You just do x equals the x value of your vertex. Then what we can go ahead and do is start filling in the chart. All right, so we have the point negative 3, 6, and we're going to plug in 2 points ahead of it and 2 points after it. So the two numbers before negative 3 are negative 4 and negative 5, and then after we've got negative 2 and negative 1. All right, so then we're going to go ahead and plug this into our function. Now, when you're trying to find your y values, and this is really important, no matter what function you are trying to get coordinates for, if you have x values, to find your y value, you plug it in. Okay, so we're going to first, let's go ahead, plug in a negative 5. So when we do that, we're going to do negative 1.5, open parentheses, negative 5, plus 3, close parentheses, squared, plus 6. All right, and so I end up with 0. All right, so that's my output for negative 5. And then, of course, I got to go plug in a negative 4. And when I plug in a negative 4, I get a 4.5 out. Now, it's totally fine to get decimals for points. I'm not going to give you any ones where there's decimals for vertex, but getting a decimal for an output of a point is perfectly fine. All right, especially when you have either a fraction or a decimal as your a value. All right, and then we go ahead. We have to plug in our negative 2. And we get 4.5. And then we can go ahead and plug in negative 1. And we get 0. Now, when you do this, if you put these numbers in order and didn't skip any, you should see kind of that symmetry, right, where the two top numbers reflect the two bottom numbers. So now we've got our points, which is great. We can go ahead and graph them. So we're going to do negative 3, 6. So we go over 3, up 1, 2, 3, 4, 5, 6. And then we've got negative 4, 4.5. So we're going to go up 1, 2, 3, 4, and then a half. So we'd put our dot there. And then we've got our negative 2, 4.5, which we can throw in. And then we have negative 5, 0. 1, 2, 3, 4, 5. Oops, I wasn't writing. And negative 1, 0. All right. So we just plot those points that we just found. Now make sure that when you draw your quadratic, you make it curvy. Don't make it look like a V. You got to add that curve to it. But that is what our quadratic's going to look like. All right. Now, for my transformations, right, you can either like explain your transformations by looking at the graph, or you could think about it in terms of your vertex form, or your vertex and your a value, really. So first off, let's look at our a value. This negative in our a value makes it a reflection, all right? You could say reflection or reflection over the x-axis, whatever you prefer. Then we have to look at the number in front here. You ignore the negative and you ask yourself, okay, is this number smaller than 1 or bigger than 1? If it's bigger than 1, you're going to have a stretch. If it's smaller than 1, you're going to have a compression. 1.5 is bigger than 1, so we are going to have a stretch by a factor of 1.5. Then for the up, down, left, right, what you really want to do is think about it in terms of its transformation from 0, 0, right? So think about your vertex. We had to go up 6 and left 3. So we would say up 6, left 3. Now, for the minimum or maximum, all right, you just have to look, okay, is it going up like a cup or down like a frown? When it's down like a frown, which this one is, you just look Does it have a high point or a low point? Well, when it's down like a frown, you're going to have a high point, which means you have a maximum. All right, a maximum value. I'm not asking for the actual value of the maximum. I'm just asking, does it have a minimum or a maximum? Then we have our interval of increase. Okay, so we have to go ahead and look at our quadratic. Now, if you're struggling with the interval of increase and decrease, it helps for you to draw your axis of symmetry in to kind of visualize your cutoff point. All right, your cutoff point is going to be your axis of symmetry. And remember, when you're giving me an interval, you're only giving me the x values, okay? So this one is asking specifically for increase. So remember, we pretend we got a little guy walking from left to right. Where is he going up and where is he going down? Well, here he's going up, all right? All right, so we can see here that right at the beginning of the graph, the little guy is walking up, which means he is increasing, and that's the part that I was asking about specifically, was where is this increasing, right? So it is increasing on this half of my graph, okay? And you can kind of think about it like you did with writing inequalities in Math 1, right? Our cutoff point here is -3, so imagine if we did -3 and shaded in this region here, right? Well, for interval notation, we would say we went from -infinity to -3. All right. Interval notation is the one where you do like the parentheses and the brackets. Inequality is where you do the little alligator symbols. Then we have, the last thing it asks for here is the y-intercept. Okay. Now, in standard form, the y-intercept is super easy. Oh, I thought I was erasing. However, in vertex form, what you need to do is plug in 0 for x. And really, plugging in 0 for x is going to be the way that you can find your y-intercept on any function. If you plug in 0 for x, whatever you get as your output, that is your y-intercept. So we're going to go ahead and go to this our function and plug in the 0. All right, and we could just do this on our calculator. So we get -1.5, 0 plus 3 squared plus 6. All right, and I got -7.5. So that would be my y-intercept. And if your y-intercept is on your graph, feel free to graph it to kind of like make sure that everything's checking out, right? So if I got -7.5, it'd be at 1, 2, 3, 4, 5, 6, 7.5. That looks pretty darn good, right, compared to the function that I drew. All right. So that's kind of a good way to check, like, hey, did I graph it right? Did I find my y-intercept right? It's a good way to just check your answer there. And why does my 7.5 look so wonky? I don't know. All right. Alrighty. So now let's go ahead and try number 2. Now, number 2 is not in vertex form. It is in standard form. And it's in standard form because it looks like this. All right. So with standard form, we have to find our vertex a little bit differently. We can't just look at it, unfortunately. We actually have to plug some values into a function. So I guess equation, really. So we know that we can find the x value of our vertex by doing -b over 2a. So in the case of this problem, our a value is 2, our b value is 12, and our c value is 17. Then we can go ahead and plug them in here. Now, -b just means, like, when I do it in my head, I just think the opposite of b, right? So if my b is 12, the opposite of b is going to be -12. Then 2 times a is going to be 2 times 2, because my a value is 2. Now, one thing you need to be really careful of is if you go into your calculator and just type this in, there's a good chance you're going to get it wrong because of the fact that it's going to do PEMDAS wrong, okay? So what I want you to do when you do these is just simplify the denominator. You can do that in your head, right? 2 times 2 is 4. So we've got -12 over 4, and then you can plug it into your calculator, okay? This is going to make your life much easier. So we do that, and we get a -3. So this is the x value of my vertex. Now, to get the y value of my vertex, Remember, once we have an x value, we can always find the y value by plugging it into the function. So we're going to go ahead and take our x value of -3 and plug it in. So 2 times -3 squared plus 12 times -3 plus 17. And I got -1 as my output, aka the y value of my vertex. Then I can go ahead, I should be able to find my axis of symmetry right now. I know my axis of symmetry is the x value of my vertex. I just do x equals that value. So I get x equals -3. Then let's go ahead. At this point, I would definitely go graph. So we're going to do our 2 points ahead of this, which is going to be -4 and -5. And then after is going to be -2 and -1. So then we're going to go ahead and just plug it into our function. So if you have the 84s, it's kind of nice. You can go up and grab and then just edit. So I'm going to go ahead and plug in a -5 and see what I get out. All right, so I got 7. And then I can go ahead and plug in a -4. And I got a 1. All right. And then we can go ahead and plug in our 2, our -2. Whoops. And I get a 1 out, which makes sense because remember, these guys are supposed to reflect. I'm just plugging them in to make sure I plugged them in correctly initially. And that's good kind of just as a double check. And I got 7 out, so that's great. So I can go ahead and graph this now. And I've got -1, or sorry, -3, -1. 1, 2, 3, 1. And then we've got -4, 1. And -2, 1. And then we've got -1, 7. So 1, 2, 3, 4, 5, 6, 7. And we've got this guy here. So this is what our function would look like. So now the transformations are going to be kind of easy. Again, for the transformations, really all you have to think about is your a value. So to find the transformation, we want to know the a value, and we want to know our vertex, which is h comma k. The a value tells us if we reflect or not, and then it tells us if we have a compression or a stretch. The vertex tells us if we go left, right, up, or down. So here we can see that our a value is 2. It's a +2. Since it's positive, there's no reflection. We don't have to write that, but we just know there's no reflection. And then since it is the absolute value of it is greater than 1, we are going to have a stretch. All right. Then I can use my vertex to figure out the up, down, left, right. So again, we have to imagine that we start at 0, 0. We went down 1 and left 3. Good? So now, let's see, they're asking for if it's a minimum or a maximum. So this one opens up like a cup, which means it has a low point, which means we have a minimum value. All right, so we would circle minimum. Now the good thing is with standard form, our y-intercept is super duper easy. It's just the c value. It's 0, the c value. So our y-intercept here is 0, 17. Well, let's say you forget that. We know that whenever we plug in a 0 for x, we're going to get our y-intercept out. So if you went and plugged in a 0 for x here, you would also get 17. You get 0 plus 0 plus 17. So you can do it both ways, but obviously it'll just save you a little bit of time if you remember that this guy is your y-intercept. All right. Let's see. Now we have our interval of increase and decrease. Okay. All right, so to find our interval of increase and decrease, it's a good idea to draw in your axis of symmetry because that kind of shows you the cutoff point. All right, and this one is specifically asking for increase, right? So we can draw our little guy here, at the very beginning, we can see him, he's going down. So that beginning part is actually our interval of decrease. And here at the vertex, he starts to go up again, right? So the part of the graph where it is increasing is going to be on this side of the graph. All right? So again, you can imagine a number line. We know that our x value is -3. All right? And we're going to shade in this side. So this one specifically is asking for inequality. So inequality is alligators. So we're going to say x values greater, oh, and I guess I could just stay there, than -3. Cool? Right? Because if this is my -3, I'm doing x values bigger than it. All right. So now we are getting to the point where we're going to write our own equations. So really you just have to think about your transformations and what that does to your a value, your h value, and your k value. So what I like to do is look at my left, right, and up, down. My vertex, if I'm going 4 right and 9 down, I'm going to go +4 and -9. So it'd be 4, comma, -9. Then we're going to go ahead. I've got a stretch of 3, so I know my A is going to have a 3 in it. And then since it's a reflection, I also need to make my A value equal to -3. All right? So we're going to say y equals -3, open parentheses, x minus 4 squared minus 9. All right, so now for the next couple of problems, we have to come up with the points on our own. And we have to come up with the equation on our own based on the information they gave us. So when you're asked to come up with an equation from either a graph, a set of points, from 2 points, what you need to do is you're going to start with your vertex form. And you're going to want to first identify your vertex, which is -2, -4. Then we go ahead and you can just pick another point to use. These ones are clearly marked. I could either use 0, 6 or -4, 6. It doesn't matter which one you choose to use. And if you happen to find other good points, you could use those as well. All right. Let's see. I'll go ahead. I'll use the 0, 6. All right. So this is going to be my xy, and this is going to be my hk. So let's go ahead and plug them in. So my y is 6, my x is 0, my h is -2, so when I do minus a negative, it becomes a positive, and my k value is -4. All right, so I can go ahead, take this, put that in the front there. All right, so then this guy goes in front of the A. So you can plug that into your calculator to get the value. And we get a 4. So it's going to be 6 equals 4A minus 4. So we could go ahead and now we need to solve for A. Okay? So we're going to go ahead and add 4 to both sides. We get 10 equals 4A divided by 4 divided by 4. So we get that A is going to be equal to 10/4. So we have 2 options here. We could reduce a fraction or get a decimal if it's a terminating decimal. So we're going to do 10 divided by 4. And I got 2.5. So you could either give me 2.5. Oh, they gave me a nice add. Creepy. All right, we get 5/2. So you can give me 5 halves, or you can give me 2.5 as your A value. All right, it doesn't matter which one you choose because it is a terminating decimal. So now we can go ahead. We know our vertex is -2, -4. Then we can go ahead and give our vertex form of the parabola, which is going to be y equals, and then I'll do the 2.5 x, and then we got a +2 squared minus 4. So that would be our equation. Now you also, of course, can give it to me with the fraction, like I said. Let's see, I'll just write it below. You could say y equals, and it was what, 5/2? X plus 2 squared minus 4. Now, they are asking for the interval of decrease. So again, we want to kind of draw in our axis of symmetry, and we want to know where the guy's going down, right? So if we draw our little guy, whoop. Oh, I lost his, let's see. We can see that when he's walking, he's going down right in the beginning, right? So we would color in this side of the graph. All right, and so it's going to be decreasing until we get to -2. And they want inequality notation. So imagine if we had our graph, -2, and we shaded in this side, right? Those are going to be x values that are less than -2, smaller than -2. All right, then we've got to come up with the answer here. All right? So we've got our vertex, which is 8, 2. How do I know this is my vertex? You need to find the point that has those reflecting y values around it. All right, so then we get that our vertex is 8, 2. And then you just need to pick one other point. It doesn't matter which point you pick. I don't know. Let's do 11 and 47. So now that we've got a vertex and a point, we again are just going to plug into vertex form. So we've got the, actually we should label them, right? H, K, X, Y. So I'm going to take my 8 and plug it in for H. I am going to take my K and plug it in for K. I am going to take my X, plug it in for X, and take my 47 and plug it in for Y. So then we get 47 equals A, parentheses, 11 minus 8 squared plus 2. So then we go ahead. Again, we need to find the coefficient on our A and put it out in the front. So 11 minus 8 is going to be 3 squared, which is 9. All right, so we're going to have 47 equals 9A plus 2. And you could just plug that into your calculator if you don't know how to do it in your head. Then we solve for A. We subtract 2 from both sides, and we get 45 equals 9A divided by 9, and we get that A is equal to 5. So we have our vertex, which was 8, 2. And then to come up with the vertex form of the quadratic, it's going to be y equals 5 times x minus 8 squared, and then plus 2. I'm running out of space. All right, the last one. All right, we have to come up with the interval of increase or decrease. So for this one, you have to sketch a graph of the quadratic. So we know our vertex is 8, 2. And then we have to say, is it going to open up like a cup or down like a frown? And we know that from our A value. Well, our A value here is positive, so it's going to open up like a cup. All right? And we know that our axis of symmetry here is at 8. And they're asking where it is decreasing, right? So we have a little person walking, and you can see that that decrease happens right away. Oh, I can't even move him. But we can see when he's walking, the decrease is going right away down, okay? So that is going to be this side of the graph. So that is values from -infinity to 8, and they wanted an interval notation. That's the parentheses bracket, so we just do -infinity to 8.